The Institut du Fer à Moulin is located in the famous Quartier Latin in Paris, not far from the Jardin des Plantes, nice cafes, and the Seine riverbanks. The Fer à Moulin street can be tracked down as far back as the 16th century, under the reign of Henry II. In 1672, the stretch of land along it was bought by the Paris hospitals and transformed into the Clamart Cemetery. In 1832, the Anatomy Amphitheatre was created on site, later to become the Surgery School of Paris hospitals. The first building dedicated to medical research was built in the 1970s. A few decades later, 3 passionate neuroscientists decided to join their forces to promote medical research on the nervous system and its associated disorders. The Fer à Moulin Institute was born. With about 90 people from all around the world, half students and postdocs, our structure is ideal to create a warm, family-like environment in which people like to enjoy science together. Today, 9 research groups, including 3 junior teams, are studying neuronal development and its disorders, such as epilepsy, intellectual deficits, or motor disabilities. 3 technical platforms are also present at the Institute: cell engineering, behavioral exploration, and the imaging platform. Understanding the nervous system starts at the molecular level. While Catherine is studying microglial gene expression dysregulation, Annelise is using super-resolution microscopy to image the clustering of single molecules at the subcellular level. In vitro cell cultures are a useful tool to model neurological disorders due to specific mutations. They can also help us to precisely identify the intrinsic behaviors of distinct neuronal populations, such as cell migration. But how do these different behaviors lead to the formation of a structured brain? Rémi is studying the neural tube morphogenesis using organoids derived from human pluripotent cells. The next step involves in vivo approaches, which help to understand how different cell populations coordinate themselves and assemble in an organized and structured manner. To visualize how the nervous system formation is processed, the IFM is equipped with a state-of-the-art imaging platform. Using light sheet microscopy, we can also perform 3D reconstructions of the architecture of the developing brain. For instance, in red here, we can visualize a brain malformation called heterotopia and assess its cellular composition. Other teams investigate the function of the neuronal network. Florian and Jérémy are using patch clamp to explore alterations in neuronal excitability associated with epilepsy. In vivo electrophysiology is another strategy to monitor neuronal networks in correlation with behavior. Here, neurons for the hippocampus are recorded in real time during sleep. Overall, the IFM is a great working environment where collaboration, mentorship, and mutual help are thriving. If you are eager to learn more about neurodevelopment and diseases, join us at the 2022 FENS Forum.